So first thing I would do is I put x squared minus 1 on the outside of the division symbol. So it'll be x squared minus 1, and then the first term will go inside the division sign, and that's x cubed minus 3x squared plus 4. So then the first thing I would do is say how many times can x squared go into x to the third, which I know that'll be 1 time. So then I'll put the x squared at the top right over the x to the third, and then down there you could put x squared.
So let me check very quick. So you got x squared up here, and you're saying x squared times x squared gets you.
Oh no, it's only one. Only it can go in 1 time. So then you put x squared down there, underneath the x to the third.
Okay, so you think there should be a 1 on top? Is that what you're saying?
No, not a 1. It should still be an x squared because only one x squared can go into x to the third.
All right, I'm going to step in there and correct that one a little bit. When we have x squared, what we're trying to figure out here for this number is what times x squared gets me x cubed. So what times x squared gets you x cubed?
Just x. No.
There you go.
Yeah, just x.
So that's the number that we're looking for over here. Is we're saying x times x squared gets you x cubed.
I get what you're saying. I messed up because I thought the x squared would go down here instead. That's my fault though. That's my fault. So yeah. So then after that, then that'll be after that, then you'll have 0 there. And then no, you still have to multiply x squared times 1 by x. So then normally like on the side, what I do is I'll do x times x squared minus 1. And then that's like how I normally would get the second half of this. And once you do that, you'll see that x times x squared is x to the third, and then x times negative 1 is negative x. So then you have x to the third minus x, which still like
perfect. Okay, now I want to pause for a second. Josh, how are we feeling on all this? Does this feel like what you're used to, or is this feeling a little bit different?
Yeah, yeah, I got it. This far.
Okay, so the context I'm going to kind of add in here is that when we're talking about, and we'll go back to the pictures in a little bit because this picture gets a little bit weird, but what you're thinking about when you're saying this, the other way of thinking about this is if I have x groups of x squared minus 1, what is that the same thing as? And you say, well, that'd be x groups of x squared gets you x cubes, and x groups of negative 1 gets you negative x. So that's why when we're multiplying all this through, we get it the same way, is that we're kind of multiplying it all the way through, and we're saying, this is what I'm about to take away from my original polynomial. I'm about to divide this away. I'm about to find x groups of this, and I'm about to pull it out. Everybody kind of understand where I'm coming from that?
Yeah.
Okay. If it feels a little bit weird, it's going to make sense a little bit when we go to the picture. So we're about to take all of this away. So that's why I'm going to subtract everything. So Davion, where do we go from here?
So then after that, you just subtract, and then you'll see that you get negative. Yeah, you get, no, there should be a positive because it's already negative. So then you'll get 2x, you should get negative 2x after that line, plus 4.
Negative 2x like this?
Yeah, plus 4.
Now, how'd you get the negative 2x?
Oh, wait, no. It shouldn't be like that. It should still be, it should be negative 2x squared. My bad. I forgot.
Okay, where are you getting the negative 2x squared?
Because you have to do negative 3x squared plus x, because this is a negative, but then like the signs have to.
Okay, so here's what I'm going to recommend you all add to your notes. When you're working through this one, take a moment when you do the subtraction and make it positive out here and distribute that negative so that you have it with each individual one, okay? So you can do that if you ever have negatives of parentheses. You can say that the opposite of x cubed minus x would be a negative x cubed and a plus x. Fair? Okay, and so then what would you try to do here? How'd you get the negative 2x?
Wait, I think Josh was saying something.
Go ahead, Josh.
So you distribute the negative on outside?
Yeah, when you're saying distribute the negative, really we're not distributing the negative, we're distributing that negative 1. So what I had written before was negative of x cubed minus x, right? And this negative on the outside can be thought of as a negative 1 being multiplied by everything, right? Me making everything opposite in sign.
Oh.
And since I have something being multiplied into addition or subtraction, we know that that's what distributing means. So you can either think of this as the pure symbolic manipulation, or you can think of it as its meaning. I've got the negative, I've got the opposite of all of this. And the all of this is an x cubed pile and a x whole. So you can do the opposite and turn the x cubed pile into a x cubed whole and turn the x whole into a x pile. However you want to look at it, it's fine.
Yeah, that's basically like easiest way that I look at it is like I know that it'll always be the opposite of whatever it is in the parentheses whenever I'm doing it. Like whenever I do division, it'll always be like the opposite of what you see in the parentheses. So like
Cool.
that's the trick you could always whenever you're looking at it and you like, oh, I don't know what I should do, you could look at it as it's always gonna be the opposite of whatever you see in the parentheses when you finna do the subtraction. So like if
Yep.
it's a negative in there, you're gonna add it, or if it's a positive, then that means you're gonna subtract that time.
Love that. So now
Easy.
talk to me here. I've got a concern with what we have written in this part. Can you find
With
what my concern is?
I'm trying to. I think there should still be a 2 here because you don't lose exponents. I don't think you would lose any exponents, so it should still be a 2 there. Shouldn't it be? It should be negative. No, it should be. Yeah, it should be negative 2x squared. It should be negative 2x squared, right?
What do you think, Josh?
Could you? I don't know. I didn't think you could like add those together.
You don't think we can add them together?
No,
How come?
because
Oh, he right.
they're different. Like you can't do x and x squared.
Yeah, them not the same terms. You're right.
What do you think, Davion?
Yeah, you're right. Because those aren't the same terms, so you can't. You wouldn't be able to do that anyway because those aren't the
Perfect.
same.
If you need to, go back to the pictures that help kind of represent them. With these negative 3x squares, you can think of them as literally being squares that are x by x. That gets me the size of x squared, right?
Mm.
Like that's what x squared means, is it means a square made out of a side of x. That's why 2 squared gets you 4, because it's a square made out of a side of 2.
Mm.
Okay? If you want to talk about something that's only x big, though, we could think of something that's maybe x long and 1 big, 1 tall. That would get you a side of x. And you can't tell me that you're able to squish these two shapes together and get a common shape or a common number of shapes. These are apples and oranges. We agree?
Mm.
Okay, so we're going to leave them separate. So that was a nice catch. So let's go ahead and take away. Let's see how we can write these when we keep them separate. And that would be what? Negative 3x squared. And I need to keep it separate from my x. True?
Yep.
All right. We did a really good job on that first round. That was all first round. What's the next round?
All right, and then the next thing you do is you say, what can x squared go in a negative 3x squared, and that goes in 3 times. Well, yeah, it'd be negative 3, so that goes in 3 times. So you put a negative 3 at the top of the division symbol, and then you multiply that, and you'll see that you end up getting the exact same thing that's already down there.
Okay, so negative 3 times x squared gets me
Negative 3x squared. That would be minus x. It'd be like the opposite of it.
so minus 3 times
No, it'd be
negative 1
positive.
gets.
It'd be positive x. I'm sorry, positive x, because a negative times a negative is a positive.
So which one are we on? Are we on the negative 3 times x squared or the negative 3 times negative 1?
X squared plus. It'll be plus. It'll be a positive, not a negative, because it's 2 negatives, and 2 negatives equal a positive. So it'll be. Let me see. 3. Yeah, so you'd end up getting negative 3x squared plus 3.
Perfect. Okay.
So
So notice that now when we're kind of recognizing that we've got this error that could happen if we're not careful with combining these terms, this is where you're going to get a suggestion from me that says don't line everything up if it's not a like term. So let's go ahead and instead write our plus 3 as being over here. Okay, so I've got all this. What happens when I subtract it? So now I'm going to subtract it all.
So
And what's
then
that going to get us?
the x squares cancel out, and then the x just drops down. So then you have x. You have x plus. I'm trying to see. Would the 4 drop down too? Or no, not yet, right?
So why don't we finish up with what we have right here, and then we'll take care of the 4 at the end, okay?
Because there'll be x plus 5. X plus 5 then. No,
So where's this 3 go?
I'm talking a 3. When you this 3 just drops down too.
So like this?
No, it would be a when you subtract the 4 too though, because that's in the same column.
What do you think, Josh?
About the 4.
Let's start with the 3. Is the 3 going to be a positive 3 or a negative 3?
Negative.
And a negative.
You think negative?
Yeah. Cause
Okay, so we got negative here. And then the 4, do we agree that we haven't done anything with the 4 yet?
yeah,
So is the 4 going to be a positive 4 or a negative 4?
positive.
Okay, what do you think, Davion?
Yeah, it'd be positive.
All right, so we'll bring it down as a positive 4, unchanged.
Hmm.
So all in all, what's that going to get me down here?
X minus 1.
You agree, Josh?
Yeah.
I'll let you both know I don't agree. See if you can find out why.
It's 1. Positive 1.
Oh, it's just to be 1. It's just to be 1.
Okay, positive 1.
Yeah.
Okay, so at this point, we could continue the process. I'll let you know it gets a little bit messy. If we're trying to figure out what times x squared gets you an x, that's a little bit harder of a question. You've got to start dealing with fractions and you get some craziness. So at this point, we are able to, because we're often asked for a remainder in our problems, just kind of say that I could keep going, but I'm going to choose not to, and I'm going to write it as saying I have my x plus 1, and I could continue if I wanted, dividing it by x squared minus 1. But
So
that's going to be fractions, and we might as well just write one fraction instead of a bunch of fractions.
Yeah, so that's what you would put in the, like, if you get to that point and you don't have a remainder, will you, like, always have a remainder?
It's not a matter of always or never. It's just a matter of sometimes it will, sometimes it doesn't. Like, that'd be like asking if I divide two numbers, is it always going to work out clean?
Yeah,
Like, it depends, right?
Yeah.
So the idea being some parts of it are always going to work out clean. You know, some parts maybe aren't ever going to work out clean. But all in all, this means the exact same thing as what we started with.
I get you.
So now what I want to show everybody real quick is just a reiteration on where all this stuff came from. So now if I'm going to clear off some space and we're going to write draw a picture of what exactly has been happening in all this symbology, because sometimes it's easy for us to forget exactly what we're doing and why. In our lecture, I told you about having like that x to 1 machine, which is really just the same thing as place values when we deal with numbers, and saying that I could take 110 and I could break that up into 10 ones, or I could take, 2 2s and I could break that up into one group of 4. Like, we can really use this idea of machines to talk about any groupings that we've ever wanted. When we do it with polynomials, things get a little bit harder, because if I talk about having x groups of x, I don't know how big that is. And so I can't really go backwards in that logic as easily. So we have to be a little bit more creative. So let me show you kind of in our lecture how we would have tackled this. We would have started with our x to 1 machine, which would have looked like this. Our x to 1 machine would have had a ones place, and I would have put 4 over there because my original problem had 4 ones. I would have had nothing in my x group because I didn't have any x's in my original. I would have had 3 in my x squared group, but they would have been negative. They'd need to be the opposite of dots, so I'll call those open circles for right now. And then I would have needed to have 1 dot that's in my x cubed. So I've got my x squared, my x cubed, and my 1s. Are we all good so far?
Yep.
Okay. Now the idea of division, if I asked you to take 500 and divide it by 2, that means find groups of 2 and pull it out of 500. We agree? Let me try that one again, make sure that we're all good. If I said divide 500 by 2, that means find 2 and pull 2's out of 500 as many times as you can, right? Like, that's how we would explain division to a 5-year-old or somebody who's just learning it for the first time. True?
Yeah.
Yep.
All right. If I'm saying instead I would like in this expression to pull out x squared minus 1, then I'm needing to look for groups of x squared minus 1 and pull them out. So I am looking for 1 antidot, I'm looking for no kind of x's, and I'm looking for an x squared, so that in my machine I've got, again, my x squared, I've got my x, and I've got my 1. We agree? All right, so here's what I'm going to try to do. I'm going to try to find these groups in my picture below here, and I need to be creative about it. So here's what we're going to start with. I want to find something that kind of sets off my little domino structure here. Here, this one will kick it off. I need nothing from the box next to it, so that's easy. There's nothing in the box next to it. I'm not going to take any of those away. And then I need to take 1 open circle from the box that's 2 lower. So I'm going to need to create an open circle. I'll create it right here. And I need to balance that out with a closed circle, because if I'm just going to create a -1, I need to create a +1 so that the meaning stays the same. Do we follow so far?
Yes.
All right, you follow in, Josh?
Yeah.
Okay. So what I found here is I found one group that is x big of my x squared times x times 1. That's why it's an x cubed, no x squareds, and an x. It's because I have one group that starts in my x box, and I've got that many of everything else. Is that fair?
Yeah.
Yeah.
All right, so I've got one group, and if I try to describe what my one group is, it's 1x cubed, it's no x squareds, and it's a negative x. We agree?
Mhm.
And then I'm going to take that away. So that means that I'm going to have no x cubes left. I'm going to have created an x dot in the process, and my x squareds remain unaffected. Fair?
Mhm.
That's exactly what you did in this line of work. You literally said, I want to take away my x cubed. I'm going to take it away. I'm going to take away an x, and in the process, I'm going to have to add an x to it.
Mhm.
And that left you with 1x. Your x squareds had remained unchanged, and all of your x cubes went away.
I'm seeing it now. I see it now.
You feeling it, Josh, or you're feeling like it's still a
Yeah.
little odd?
Yeah, I get it.
Okay. And that's why every time when I'm asking you, what do we multiply up here times x squared to get our leading coefficient, it's because we're trying to do the same process. The next thing I would do in my picture is I'd start with this part of the domino, and I'd say I need to find 3 groups. Like I need to find the opposite of 3 groups because I'm looking to do the opposite of this dot up here. So you'd say, well, I need to do 3 of them, and then consequences. I would need to create some dots over here. We could do that one pretty quick. Let's do it here. I want 3 groups. I'm going to start with this one. I need nothing in the box next to it, and then I need 1 of the opposite from the box following. So that's 1 group. I could do it with another group. I could do it with a third group. So that gets me 3 groups. My x remains unaffected, and I have 1 left over. So I've taken away 3 of them, taken away 3 from my 4. My x remains unaffected, and I'm left at the very end with saying I have 1 of these dots in the x box, 1 of these dots in the 1 box, and I can't create these dominoes anymore. So I'm going to leave that as my remainder. How do we feel about that?
That's pretty.
Let me see.
Why they don't teach that?
You liking it?
Yeah.
It's crazy when you
That's
go back
the
to what
thing
things mean
you
instead
do
of
that.
trying to focus on the rules. It makes understanding the process so much easier. It also makes sense why it is that a lot of times in the rules, they say that you should always take a moment and you should put in plus 0x here, right?
Mhm.
The reason is because you have a space that you are going to have zeros in, and you need to make sure things don't get confused. So sometimes putting in those placeholders here is nothing more than reminding us it all comes back from this machine.
Yeah, I get what you're saying.